So to work out the energy dissipated in a wire and how much it will heat up. Firstly, let's write down the things we know. We have 10 metres. We have a diameter of 1 millimetre, which is 1 by 10 to the minus 3 metres. We have the resistivity ρ equals 1 by 10 to the minus 6 ohm metres. And we have a voltage of 12 volts. So let's start with resistance. Resistance equals ρ L over A. And A equals pi r squared equals pi times half the diameter, which is 0.5 by 10 to the minus 3 squared, equals 7.85 by 10 to the minus 7 square metres. So resistance is 1 by 10 to the minus 6 times 10 over 7.85 by 10 to the minus 7, and that is 12.7 ohms. So B then is fairly straightforward. The current, which is V over R, is 12 over 12.7. We have 0.95 amps. And now power's fairly simple as well. P equals V times I equals 12 by 0.95. It is 11.3 watts, so close to 11 watts. And I'll do the rest over the page. Now for part D, if our power is 11.3 watts, the energy is power times time, but we need time in seconds. So 10 minutes is going to be 10 lots of 60 seconds, so 600 seconds. So the energy is 11.3 joules per second going for 600 seconds, and we have 6,800 joules. Now for the last bit, we're using the equation that Q, which is the heat energy added to an object, is its mass times its specific heat times its rise in temperature. Now 6,800 joules is the amount of energy being added to this wire. We are given the specific heat. So the specific heat of nichrome is 450 joules per kilogram per degree C. And the other thing is we have the density, which is also ρ, but this is now density ρ, is 8,400 kilograms per cubic metre. So we know the specific heat, we know the energy, we want to work out the rise in temperature, so we need the mass. Now we know that density equals mass over volume. So mass equals density times volume. Now the volume is just the cross-sectional area times the length. Now we worked out the cross-sectional area. It was 7.85 by 10 to the minus 7 times 10, which is 7.85 by 10 to the minus 6 cubic metres. So the mass is 8,400 times 7.85 by 10 to the minus 6, meaning that we have 0.066 kilograms of nichrome, or 66 grams. So now substituting into this equation, we have 6,800 joules is 0.066 kilograms times 450 being the specific heat, joules per kilogram per degree centigrade times our change in temperature. And that gives change in temperature 6800 0.066 times 450. That gives a rise in temperature of 230 degrees, which seems a lot, but it's a long way short of its melting temperature, which is well over 1,000 degrees. And just out of interest, if you've ever done heating water with nichrome wire and they've left a bit of wire out of the water, you can actually see it glowing red. Glowing red means, in fact, it is quite a bit over 500 degrees. So this rise of 230 degrees, you certainly wouldn't want students to touch it, but it wouldn't yet be glowing red. So I've certainly seen nichrome a lot hotter than that.